What do you notice about the hypotenuse for both? Yeah. They're both 1. So what I want you to do right now, okay, since our hypotenuse is 1, I want you to find both side lengths for 45, 45, 90, using what we know with the hypotenuse equals, and the same thing for 30, 60, 90, okay? I want you to take a minute. You definitely can consult with a partner near you to go through to make sure you're on the right track in terms of both side lengths. That's where I want you to start. If you need to have your 6.1 notes out, I'm just going to borrow yours for a second, where it shows this, or even the practice we just completed, it's kind of hard to see in this gray box, so this might be easier to remember what the side lengths equal. Start with your hypotenuse is 1, okay? Now I want you to find both side lengths for 45, 45, 90 and 30, 60, 90. So we know 40, excuse me, 45, 45, 90, both side lengths are the same, and this is equal to x root 2, right? So in order to find the side lengths, we have to solve for x. So when we take 1 equals x root 2, we divide by root 2. However, can we have a radical in the denominator? What do we do to get rid of it? Yeah? Multiply by root 2. So both side lengths are root 2 over root 2. Over 2. Okay? So a lot of you did have that, or at least the start of it. Okay? So both side lengths are root 2 over root 2. Now, for 30, 60, 90, our hypotenuse is equal to what? 2x. Okay, so we know across from 30 is x, and we know across from 60 is x root 3. So, in order to solve, we divide by 2. So x equals 1/2. Okay, that's across from 30. Now 60 is 1/2, which a lot of you had, 1/2 times root 3. Yes, you are correct. However, can we multiply those together? Yeah, because root 3 is over 1. So we could just multiply across. So across from 60, our side length is root 3 over 2. Okay? Questions? All right. So now we're going to take our new side lengths, or what our side lengths are, and find sine and cosine. Okay? So the sine of 45, we could choose whatever angle we want. Okay? So say if I use this one, sine of 45. Sine is what in terms of SOHCAHTOA? Opposite over hypotenuse. So we have root 2 over 2 over 1, which is just root 2 over 2. Cosine of 45 would be what? Yeah, Mia. Yep, root 2 over 2. Because it's adjacent over hypotenuse. Okay? So now we move over to our 30, 60, 90. Okay? So the sine of 30, here's our 30-degree angle. Sine of 30 would be what? Sine, remember, is opposite over hypotenuse. What would the sine of 30 be? Emily? 1/2. Good. What would the cosine of 30 be? Liam? Good, root 3 over 2. Okay. Now we move on to 60. Well, here's 60. What is the sine of 60? Emily? Root 3 over 2. What is the cosine of 60? 1/2. Excellent. Okay. So why are we doing this? Why do we need to do this? Well, these are going to be our key values to fill out that whole circle I told you is our end goal today. Okay? So, knowing these values will help us go deeper into trig. Are we ready? Okay. Today we are learning about the unit circle. Okay? It's a helpful way to find trig ratios for angles or multiples of 30, 45, and 60. Okay? When you look at a circle, first of all, a circle is how many degrees? 360, right? A circle is 360. Okay? We are going to have a radius of 1. Okay? We are going to have a radius of 1. Therefore, our hypotenuse is 1. Hence is why we did those two triangles above. So all the way around, our radius is going to be 1. All the way around. Okay? So when working with right triangles, we use the Pythagorean theorem. Okay? A, B, and C was our hypotenuse. Okay? We know that. A squared plus B squared equals C squared. But now, since we're graphing these triangles on the coordinate plane, on the XY plane, we are replacing A and B with X and Y, and C with your radius. Okay. So therefore, our equation is going to change a little bit. X squared plus Y squared equals R squared. Some of you might remember from geometry, if you got to it, an equation of a circle. That's an equation of a circle. Okay? This equation is of the unit circle. Okay? Where the center is 0, 0 always, that is not moving, and our radius is 1. Okay? So, to help us fill out this unit circle, before we begin with any of the colors, I want you to identify your hypotenuse as 1 all the way across, okay, for all three triangles. Okay, the easiest triangle that we know both sides of are 45, 45, 90. Both sides that we just found are what? For 45, 45, 90. Yep. Good. So root 2 over 2, root 2 over 2. Okay? Now, for 30, 60, 90, if you notice we have two triangles here. We have one starting with 30 and one starting with 60. So, for your 30, 60, 90, across from 30 was what value? Emily? 1/2. Good. Across from 60 is what? Chris? Good. Root 3 over 2. So now, if I switch to where my 60 is now at the bottom, this side length is what out of these two values? Anna? Across from 60 would be what? Root 3 over 2, and our shorter side length is 1/2. So these two guys just switched places. Okay? All right. So I want you to take your first color, and I'm going to use highlighters up here. Okay, I want you to take your first color, whatever you choose to use, and kind of color the outside of 30. Okay, so you can see the difference of colors. For 45, choose a different color. And for 60, choose your last color. Okay, as long as you can see the colors, you might have to do thicker lines around it so you can see the different colors. I'm using blue for 30, green for 45, and pink purple for 60. Okay, so these are just special rights. Okay, so now we're going to look to see what if we include them on a coordinate plane to create the unit circle. The first part by far is the most important. We are filling out the first quadrant of the circle. That is our most important to fill out the rest of the circle. Okay, so with your first color again, okay, this is 30 degrees. Outline that triangle in the same 30-degree color. Okay, then we're going to label that this is 30 degrees, okay, and our side lengths are 1/2 and √3/2. So this is what it looks like on the unit circle, okay, how the triangle is created and used. Okay, we're going to do the same thing for 45. Okay, so all we're doing is taking above and copying it down. Okay, so this is 45, and I know this is √2/2. Okay, now we're going to do the same thing for 60. Okay, everyone good? Okay, so what we just did is took above and now put it on the circle. Okay, so now we are going to eliminate these two lines and just highlight this first line here. Okay, so we're going to highlight this line as our 30-degree angle. Okay, we took out the other two pieces of the two sides of our triangle. Now, if I know the side lengths are √3/2 and 1/2, how would I write that as a point on a circle? How would I take those two side lengths and write it as a point, an ordered pair? What do you guys think? Look at what we have here. Think of your XY plane. How can I write those side lengths as a point? Tyler. Excellent. Okay, so we're taking our two individual side lengths, which it looks like, and creating an ordered pair. Our horizontal is our X value. Our vertical, or up and down, is our Y, which is 1/2. So we're going to jot down 30 degrees and write √3/2 and 1/2 as our point on that circle. Okay, We're going to do the same thing for 45 and 60. Excellent, Tyler. Okay, so we're going to do 45. And what would that coordinate point look like for 45? Yep. Good. Root 2 over 2. Root 2 over 2. We're going to do the same thing for 60. What would that coordinate point look like for 60? M? Good. Okay, so we're almost there. Okay, we have 3 out of the 5 pieces for the first quadrant. Okay, we have to figure out what the x and y intercepts are. So before we do that, I want you to do the same thing, however, write them all together. Okay, so what I mean by that is take your first color, highlight this line, take your second, and your third. I want you to fill out the degrees, as this is 30, 45, 60. And then we have our coordinate points. So we're literally just piecing together the 3 individual above into one picture. Okay, so there's 2 little bookends there, okay? We have this, and we have this, okay? So in terms of degrees, okay, if we had to think of degrees, what would this degree be? 90. And what would this be? What do you think? Then 0. This would be 0, okay? So 0, 30, 45, 60, 90. Now, how can I figure out what these points are? Those are our x-intercept and our y-intercept, because remember the circle is all the way around, okay? What do you think it would be? Finn? We don't need to. We don't need to. It's okay. We don't need to. Good thought, though. What do we think? What's our radius all the way around? 1. Okay. Liam? Which one's 0, 1? 0 or 90? 90. Good. So 90 degrees is 0, 1. Okay? Because our radius is at the top. The full length from the center to the top is 1. So therefore, what would this be? What would our x-intercept be here? 1, 0. Good. So our x-intercepts are 0 and 90 degrees, x and y intercepts. Okay, at 0, it's 1, 0, which is your x-intercept. At 90, it's 0, 1, which is your y-intercept. Okay, are we okay? Quadrant 1, think of quadrant 1. Both x and y are what? What is it? Positive. So quadrant 1, X and Y are both positive in quadrant 1. So if we continue to do this in quadrant 2, what's now going to happen? What are we going to notice in quadrant 2 in terms of X and Y? Yeah. Good. The X would be negative and Y would be positive. So what I want you to do first is fill out the first quadrant. Okay? The same way we just did. So if you have to refer back to your notes, you can. So you go with your first. I want you to just fill out the first quadrant. Okay, exactly as we just did, including degrees, so we don't lose track of those. Okay, so now, what do you think we have to do in order to fill out the second quadrant? Is there anything that you guys notice that can be helpful? Or, yeah, Stefan. Okay, so all of our next X values will be negative, right? Okay, great. So how can I determine what colors I will have on this side? Like, how can I determine where those coordinates will go? What do you think? Yeah, Finn. Okay, so be a little more specific. So, this line here, according to mine, would it be blue, green, or pink? Blue. This middle line? This one? Excellent. Okay, so these are similar angles. However, our X values are just negative. We don't have to do anything else. Okay, so we're going to fill out our colors, okay, for these three. So we're going to do my blue, green, and pink. Okay, so my blue, like Finn said, we have negative root 3 over 2 and 1/2. We have negative root 2 over 2, root 2 over 2, negative 1/2, and root 3 over 2. All right. So now, if I come across, we already determined a full circle, which we know is 0 to 360, right? 360 degrees. So half of it would be what? 180. This is 180 degrees. So what would be my other x-intercept then on this side? Yeah. Negative 1, 0. Okay? Negative 1, 0. Go. Okay? So I still have to fill out these degrees then. I have to fill out these degrees. Any idea? How can I figure these out? What would they be? What do you guys think? How about if I choose this angle here? What would that be? Nick? Oh, okay. Tate? 150, how'd you get it? You are correct, by the way. Excellent. 180, because this is a 30-degree angle. 180 minus 30, which is my blue line, is 150. What would my green line be? 135. 180 minus 45. Good. And then my pink one up there, Porter? 120. Okay? One thing what we just did, what Tate actually brought up, is you always want to use the x-axis, never the y. Okay? Always the x-axis to do that subtracting for. But also realize from your x-axis to your first angle, 30, then it's 15 in between, and then 30 again. Okay? There's definitely tricks you guys are going to come up with as you learn more about the unit circle. Okay? So, we did quadrant 1, quadrant 2. Okay? So just before we get to quadrant 3, how can we find angle measures in the second quadrant? Refer to quadrant 1. How can we find the coordinates? Quadrant 2, x is negative, y is positive. Our new x-intercept is at 180 degrees, and that's negative 1, 0. Everything we just wrote above, okay? So now, if we add to quadrant 3, what's going to happen? Nick? Excellent. X and y in quadrant 3, x and y will both be negative. So right now, I want you to fill out quadrant 1 and quadrant 2. If you feel confident, however, be careful filling out quadrant 3. You may, but just be careful, okay? We're going to do quadrant 3 together. But first, we're going to fill out quadrant 1 and 2. Don't forget the degrees either, you guys. Yeah, Rory. Okay. So hopefully you have quadrant 1 and 2 filled out. We just did. Okay. Now moving on to quadrant 3. What would our new y-intercept be? What would our new y-intercept be? Yeah, Tyler. Here's 180. Non-negative, you would add 90 to 180. 270, good. 270 would be our degree. What would be our coordinate point? Nick? 0, -1. Good. Okay. So, looking at quadrant 3, our first line, what color according to mine? Blue, green, or pink would it be? Zach? Which one? Be careful. Be careful. The first line here. It would be blue. But that happens a lot, switching the blue and pink. A lot, okay? So what I want you to follow is from the first quadrant. If you follow that line, that's going to be identical to 30 degrees. So from the first quadrant, if you follow, it's going to be the same. Also, the distance here is the same as that one. Okay? So, highlighter blue. All right? What would the middle one be? What color? Yeah. Green. And then we have our pink. Okay? So, since this is a blue, we're going to have root 3 over 2 and 1/2. However, both are going to be negative. Okay. What would my degrees be then? Nick, go ahead. Yep. Excellent. Good. So, from 180, we added 30. Okay. From 180, you could add 45. 180, you add 60. Okay. So, our new y-intercept was at 270, and it was 0, -1. Okay. So, if you guys notice, out of all these quadrants we've done so far, what is the most important? Yeah. Quadrant 1, because isn't it the same all the way throughout, right? So now we're going to finish the circle. Quadrant 4, what is the deal with quadrant 4? Who could tell me? What's the deal with quadrant 4? Good. So quadrant 4, positive x, negative y. So go ahead with your colors right now. Fill out 1, 2, and 3. You can start quadrant 4, but just be careful, okay? So we also said one full circle, 360. So 0 and 360 will have the same coordinate point, okay? So looking in quadrant 4, which line will be blue? First, second, or third? Okay, first, second, or third. Which line would be blue? Excellent. The first one would be blue. Then what? We have our green and then pink, okay? Quadrant 4, I see a lot of the coordinates for these two switched. Remember, you're always calculating from the x-axis, not the y. All right, so let's finish this guy off. So we have root 3 over 2 and negative 1/2. Root 2 over 2 and negative root 2 over 2. 1/2 and negative root 3 over 2. There you go. Ladies and gents, you filled out the unit circle completely. Okay? So, this is a lot to kind of process and digest. Okay? However, if you know quadrant 1, you know the rest of the circle. We have to finish up, actually, the degrees. Sorry. Okay? You're just going to say that? Okay. So, from 270, this purple, actually, let's go from 360. Actually, purple. From purple, what would this be? 300. And then what? Green would be 315, and then 330. Excellent. Now you have completed the unit circle, okay, with our degrees. So you guys will be required to, every class that you come in, because this is how important it is, you will be filling out a unit circle every single day, okay? That's how important it is. Yeah. It's used for graphing. It's used for, a lot is used for graphing, actually. We will be getting into next class the exact values. You're correct, though. The exact values with sine, cosine, and tangent based off of what's given. You could, for word problems, we will be using this for Ferris wheels, because doesn't it kind of look like a Ferris wheel? You know, because this is where you start, get on from the platform, not really from the bottom, and you go up this way and around, so that's where it kind of relates to. Tides, waves. I know, because that's the biggest question, don't we ask all the time in math anyway? When are we ever going to see this? When are we going to use this? Blah, 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 blah. It happens all the time. So that's a great question that comes up, okay? So one thing, okay? There's two little minor things, okay? First thing for your homework, okay, is to fill out this blank unit circle. I want you to try from memory, though, okay? So look at your completed one, start with the first quadrant first, and go from there. Obviously, if you have to refer to your notes, you can. I'm not that mean, okay? Then there's going to be a short, it will be posted a little bit later, short delta math. Short, very, very short, okay? On our special right triangles and all that good stuff. Awesome, awesome, awesome job today, you guys. Make sure I get the color